Students, be ready for what is truly a difficult algebra lesson. In this lesson, we are going to be talking about integer exponents. That means we're going to be dealing with exponents that are positive, which we've done before. That just tells us how many times we're multiplying a number. 2 to the fourth means we're multiplying 2 by itself 4 times. We're also going to be dealing with exponents like 0, which is a little bit different, and then exponents that are negative. And things are going to get a little bit wonky, okay? Here's what I need you to do. I need you to really tune into this lesson. Really pay attention. Algebra boys and girls, I need you to grow up and become algebra men and women, okay? Because we are going to be working with some pretty complicated stuff. And if you are still at this point in algebra struggling with, oh no, when I multiply a negative by a negative, is it positive or is it negative? Or if you're still having a hard time with things like, hey, this is 2 times 3 to the fourth. I'm going to multiply 2 times 3 first and then raise it to the fourth. Instead of doing the exponent first, like you really got to know your order of operations. You really got to know how to keep track of those negative those negative signs. If you're still struggling with stuff like that, things are going to get really difficult for you in algebra very quickly. So what I need from you is, if you're still struggling, you need to really buckle up and try to understand stuff by really spending some time thinking about the homework problems, okay? This is the first lesson where we're going to be learning something that is 100% new, that's an actual algebra technique. I don't think you've ever touched this in the past before. Let's get started. Now, this is familiar. Here are some powers of 2. 2 to the fourth. 2 times 2 times 2 times 2 is 16. 2 to the third, 2 times itself 3 times is 8. 2 times itself 2 times is 4. 2 to the first you can make sense of. We just have 1, 2 there. That equals 2. But now what happens when I go down one more value of an exponent and I do 2 to the 0? Okay, so here's the first thing you need to realize. A number raised to the 0th power, as long as that number isn't 0, okay, 0 to the 0 can't be evaluated. But as long as we just have a regular number raised to the 0th power, the answer is always 1. Anything raised to the 0th power is 1, and I can show you why in just a minute. All right, what about 2 to the negative 1 or 2 to the negative 2? What if I start raising things to negative powers? Now, here's what I tell students to help them understand negative exponents. A negative exponent just means that the number is on the wrong side of the fraction sign to have a positive exponent. So how do I make this exponent positive so that I could actually evaluate it? Because I can't do much with a negative exponent by itself, but I could evaluate a positive exponent. I could do 2 to the first, just not 2 to the negative first, or 2 to the negative second. I can't do anything with that, but I can do 2 to the second. Well, here's the thing. If you take that number and move it to the other side of the fraction bar, instead of 2 to the negative first, what if we had 1 over 2 to the first? When you move the number to the other side of the fraction bar, the negative exponent becomes positive. So 2 to the negative 2, if I put it under the fraction bar, 1 over 2 to the positive 2, that's the same thing. And then 1 over 2 to the positive 2 is just 1 over 2 times 1 over 2. Or actually, it would be 1 over 2 times 2, which would be 1 over 4. That's how you deal with negative exponents. Now, we're going to give that lots of practice in just a moment. But before we do that, let's talk about some properties we need to know. Negative and 0 exponent properties. First of all, if you have a negative exponent for every non-zero number x, this only works if your base is not 0. If your base is 0, you're going to do a division by 0, and it's going to be undefined. You can't do it. But as long as x, your base, is not 0, if you have x to the negative n, it's the same thing as flipping x to the n to the other side of the fraction bar, and just making sure on the other side of the fraction bar, your value is positive. Your exponent value is positive. So that under the fraction bar there, we have it's 1 over x to the n. If I wanted to, I could take x to the n and put it underneath the fraction bar, even though it has a positive exponent, And when I move it to the wrong side of the fraction bar, all of a sudden it gets a negative exponent. So do you see how I could do that? What if I have 1 over x to the n? What if I have this? Can I change it so it has a positive exponent? Yeah, I could just lift it to the other side, to the top of the fraction bar. If I have a negative exponent in my denominator, if I move that value to the top of the fraction bar, the exponent becomes positive. All right, now this isn't probably making a whole lot of sense with n's and x's. We'll do this with real numbers in just a moment. And then let's talk about the zero exponent property. As long as you're not dealing with a base of 0, anything raised to the 0 is 1. And that's just a property you need to memorize. All right, now this is where if you don't know how to add and subtract negative numbers, things are suddenly going to get very difficult for you in algebra. The quotient property of exponents. This is it. If m and n are real numbers and x is not equal to 0 again because we can't divide by 0, then x to the m divided by x to the n. Notice I have the same base on the top and the bottom, okay? You're going to see that's a common pattern down below. I have to have the same base on the top and the bottom for this to happen. When I divide x to the m by x to the n, all I do is I subtract my exponents, the one in the denominator from the one in the numerator, okay? Or if I wanted to, I could flip around the exponents and do n minus m, but it would have to be in the denominator because that's that thing where I'm going on the wrong side of the fraction bar, so things are going to become negative potentially down there. Let's just take a look at what this looks like in practice. So here I have 5 to the 4th divided by 5 squared. Well, so I have the same base. Okay, that's the first thing we're going to check. 5 is my base. It equals 5 to the 4 minus 2, or 5 squared, which is 25. If I were to work these out, I do 5 times 5 times 5 times 5 over 5 times 5. What's going to end up happening is 2 of these 5's in the denominator are going to cancel 2 in the numerator. So I end up just reducing the exponent in the numerator by 2. Hey, what if I have 5 squared over 5 to the 4th? Well, okay, they did it this way, but I just want you to think. It still works. I can do 5 to the 2 minus 4. What's 5 to the 2 minus 4? 2 minus 4 is negative 2. I would have 5 to the negative 2, but remember, if I have a negative exponent, that means I'm on the wrong side of the fraction bar, and I should probably move the thing to the other side. 5 to the negative 2 is just 1 over 5 squared, 1 over 5 to the second. And then I'm just going to square that 5 to the second in the denominator. I get 1 over 25.